Okay, so we're supposed to find the mean, median, and mode of the data, identify the lower and upper fence. There's a lot to do. I'm going to use my calculator for this. I'm just going to call this data. 17, 21, 19, 10, 10, 14, 0. I like to count it and make sure I have the right number. 3, 10. Got 10 pieces of data. I think I typed them all in. They look about right. Okay, so I'm going to do one variable stats. So I'm going to add a calculator page. In menu 6, 1, 1. And the list is going to be data. So I've got the mean is 14.2. Median is 15.5. Mode, I'm going to figure out in a minute. The upper and lower fence. Okay, so we've got to use Q3 and Q1 here. So let's see, Q3 minus Q1, the IQR is 19 minus 11, which is 8. So the lower fence formula is Q1 minus 1.5 IQRs. So that would be Q1, which is 11, minus 1.5 times 8 is 12. Wow, so lower fence is -1. There's no outliers on the lower end, although that's close. Upper fence is Q3 plus 1.5 IQRs. So Q3 is 19, plus 12 is 20, that's 31. Don't think we have any outliers, so no outliers. There's nothing bigger than 31 or less than -1. I can, if I want to, sort A of data. I can even type data. Whoops. It'll list it out for me instead of looking back at the other page. And it's all in order. Is there any? 19. So 19 is the mode. You can just see it easier when they're put in order. Because I could have seen it from there, but just easier spot. So make a box and whisker plot. So let's do this. So I'm going to call this list 1. Don't put a space in there if you do something like that. 7, 12, 13, 14, 17. See, 1, 2, 3, 4, 5, 6, 7, 20 pieces of data. Just a lot to type in. So just kind of double checking it. Okay. We go to this one. Let's do one variable stats. So I really need my 5-number summary. 1 and 20 is the minimum maximum there. Not a bad idea to figure out your upper and lower fence here first. So lower fence would be Q1, which is 4.5, minus 1.5 times IQR, which is 20 minus 4.5 is 15.5. And upper fence would be 20. No, let's see, 15.5. Ooh, wait. I think I did the wrong thing. Q3 minus Q1 is 15 minus 4 is 11. So that's 11 right there. Sorry. Plus 1.5 times 11. That's the IQR. Q3 minus Q1. And then I'm just going to type those in my calculator. So negative 12 and 32. Doesn't look like we have any outliers here, so so let's just do 40, 30, 20, 10, 0, negative 10, negative 20. Okay, so the upper fence is at 32. The lower fence is at negative 12. Let's see the 5-number summary. Let's get back there and look at it. So 1 is your min. 4.5 is Q1. Q1 is 4.5. Q1. 10.5 is the median. Q3 is 15.5. And the max is 20. You can definitely connect those lines because there are no outliers here. If you needed to do that on the calculator, see if we did it right, I guess. So 1, 4.5, 10.5, 15.5, and 20. And that looks pretty good. Somewhat symmetric, just overall. Find the mean and standard deviation of the data. Plus one data 2, 78, 90, 456, 673, 11, 381. So mean is 298.167. Standard deviation is 223. Wow, 0.27. It's pretty big standard deviation for this one. Numbers are all over the place, I guess. So if I'm doing this problem, you can set it up algebraically if you want to. I'd say you have 5 test scores and you want to get an 86 average. So 86 times 5 is 430. Add up the other test scores you've already done. .430 minus 328. You've got to get 102 on the last test. How many of the games did the soccer team score goals equal to the median number of goals for the 29 games? So I like to put these numbers up top. So this is 8 of these guys, 9, 6, 3, 2, and 1. So there are, well, I guess there's 29 games, right? So 29 games. So 29 divided by 2. 14.5, so the 15th game. I'm looking for the 15th game. Counting from the left, there are 8 there and 9 there. Somewhere in this bar is the median because there's 17 there, and I'm looking for the 15th term. You also could have counted from the right as well. How many of the games did the soccer team score goals equal to the median number of goals for the 29 games? So 2 is the median, and that happened 9 times, so 9 times. Okay, make a stem and leaf plot. So it looks like 5, 6, and 7. Kind of the easy way to do this. I'm just going to try to do it by hand here. So 5, there's only a couple of them. That would be 5.06 and 8. Underline the 6s here so I can kind of think through them. So a lot of 6.3s. 4. There's one 6.4, one 6.5, one 6.6, 7, and 8. Okay, I think I got all those, and then 1, 2, and 2. I think I got all those. Okay, and the key would be something like this. 7 bar 2 equals 7.2. And a bunch of stuff to identify here. So I need the calculator. So the population for this one would be this all of this particular supermarket of this particular supermarket's shoppers. The sample taken from the greeting card aisle. Sampling method is certainly a convenience. Randomization, no, convenient method is not randomized. Bias, I mean, I'm not sure. Greeting card aisle, you're talking about people who are very thoughtful. So maybe thoughtful people use coupons more often. I'm not sure. So I think there is potential bias there as to where, because of the location. and maybe those people are especially, there could be response bias. We're not sure. Do greeting card shoppers represent a typical shopper? A typical shopper. So I guess that'd be the question. Okay, what's the population? People who watch ESPN are the population. Um, the poll or the sample was those who responded to the poll. What was the other questions we asked? Sampling method. Okay, so this is self-selected. Is it random? No, random. Is there bias? Only people with strong feelings will only passionate sports fan, not the average fan, but just passionate about NBA basketball would respond. Population is all the students at a large public high school. Sample a group of boys and girls. They were separated first, then sample. The method is definitely stratified. I don't know if you see that. But because they were separated first, it wasn't just like put everyone's name in a hat, draw out, we might get 5 boys, 10 girls. They were definitely stratified because they were grouped first and then a simple random sample within each homogeneous group. Was it random? Yes. Simple random sample was performed within each group, so that is random. And is there bias? Don't think so. Not that I know of. There always can be bias, but not from the information we've been given. Don't you agree? 16-year-olds because they're responsible and informed. So, it's leading, it's loaded, it's leading and loaded, something like that. Oops. I think this is a pretty good question. Twins are not good samples. So I'm okay with the first one. It's maybe not the greatest, but I can deal with that. This one is problematic. So I would think everyone who shops at a pet store owns a pet, just about. I mean, I guess you're buying a gift, I guess, but it seems biased because everyone, if you go to a pet store, you own a pet, so almost 100% would own a pet, and we know not everybody owns a pet. So at the beach, name your favorite vacation spot. The beach. That might be their favorite answer because that's where they're at. Maybe they're beach vacation people. I really don't like that question at all. I'm okay with D. I mean, nothing's perfect, but um, the two worst ones are B and C there. So mean is 45, 55. Always go 3 standard deviations out. 25, 15. Between 35 and 65. So we know 34% and 34% because that's 68%. From memory, I think this is 13.5 or 27%. Because remember, 2 standard deviations, 95% of the data was in that. So 95 minus 68 is 27. 27 divided by 2 is 13.5. So I'm just going to add those up. 68 plus 13.5, 81.5. Greater than 65. So you could do this plus this and subtract that from 50%. So 50 minus 34 minus 13.5 is 2.5. We know also that 99.7% of the data is between those two. You could use that information if you needed to. According to line of best fit, which find the closest predicted increase for every 1 increase in gram of protein. So we're looking for the slope of this line, essentially. So it looks like it would cross about there and maybe close to here. That's not perfect, but 50, 80. This would be 10, 20. I like to pick points far away. So it'd be 60 is the change in y divided by 40. About 1.5 is what I got. That's pretty good. Wow. So you should kind of picking out some points and finding that slope. What's the number 72 represent in the function? I'm thinking initial something right away because that's the y-intercept. The y value seems to be the height here. The x value is the time, h of x. So the initial height and speed of the object, in feet of the object. So this should be change in y, minimum wage dollars per hour divided by change in that. So 0.096. So this is 0.096 changing, and this is by every year. So 0.096 divided by 1 is the fraction there that we're talking about. So each year between 1940 and 2000, the average increase was $0.096. Each year between the average increase in minimum wage was $0.49. So I don't think that, I'm leaning towards this one, but I'm just looking at all of them. The average was 0.096. No, not every 10 years. I don't think so. So I'm picking A. It was only 9 cents. Is that right? Each year, I guess it increased by 9 cents. So if you're increasing each year, that's like 90 cents. Yeah, it's about right. It's increasing about 90 cents. Takes a while, huh? That's about right. About to have a big jump. Maybe we'll see. If there's a big push politically, to raise the minimum wage. I'm not sure it'll go up to 15, but it might go up sometime. It hasn't gone up in a while. Scatter plot above shows a company's ice cream sales in dollars. Line of best fit, which the following could be an equation, line of best fit. Be careful on this one. This one's, I think, a really tricky problem. Like we did on one of the previous ones, we're going to try to get some nice points in here. So, man, it's hard to find some nice points. Let's just pick up this point. That seems to be about 20. Well, let's pick up that point, I guess. That's 25, comma, just a touch over 900, 910 maybe. And let's pick a point down here. Let's say 13, comma 500. So 910 minus 500 is 410. Divided by 25 minus 13 is 12. Let's see. 410 divided by 12. So around 34. Okay, so it's definitely one of those. It's positive. Boy, it's hard to figure out what the y-intercept is going to be. The reason why it's tough is because this is 10. So really like, this would be like 8, 6, 4, 2, 0, like way out here somewhere around there would be that point, which I think has to be this one, but you could actually kind of plug in. So we could do y equals mx plus b. We know the slope is 33. I know I guessed 34 there a minute ago, but and let's take one of these points. Let's take this point. So y is 500. X is 13. We don't know b. So 33 times 13. Subtract that from 500. About 71, which is closest to 84, so it's got to be this one. But that was really a challenging problem because notice it helped to get the slope, but then we had an issue with the y-intercept was deceptive. It wasn't really there at 10. It's when temperature is 0. Okay, that's your review.